Okay, you're good to go.
Okay. Do you guys know what this is?
No.
It's the blue planet. It's the blue marble. It's Gaia. This is Earth. It is the third closest planet to the Sun, the densest planet in the solar system, the largest in the solar system's four terrestrial planets, and the only celestial body known to accommodate life. It is home to millions of species, including a global population of humans that are supported and nourished by its biosphere and minerals. The human population is grouped into around 200 independent sovereign states that interact, among other means, through diplomacy, conflict, travel, trade, and media. So, Earth was formed around 4.5 billion years ago, and in the first billion years, life appeared in its oceans and the atmosphere started to change. In the layer and Earth's magnetic field, which is the outside, blocks the most life-threatening parts of the sun's radiation, so life was able to flourish on land as well as in water. So after the 1 billion years, more life was able to be produced on Earth. And since then, Earth's position in the solar system and its physical properties and geological history have allowed life to persist. So the first billion years of Earth, this history has never allowed life. It's after that. So Earth's lithosphere is divided into several rigid segments or tectonic plates. So if you know where we are, we're in Vancouver, and that's where tectonic plates, that's why we are prone to having earthquakes. So these tectonic plates are constantly moving, but then it happens over the course of many years. Over 70% of Earth's surface is covered with water. Those are the big oceans. And with the remainder of the space, which are islands and continents, which we live on. So Earth's poles are mostly covered with ice, which is Antarctica and the north. So Earth gravitationally interacts with other objects in space, especially the sun and the moon. One orbit of the Earth takes 365.26 solar days, and that is one sidereal year. Earth rotates about its own axis 366.26 times during that 365 days. The Earth's axis of rotation is tilted 23.4 degrees away from the perpendicular of its orbital plane, which is why we have seasons, and which is why different parts of the Earth are different seasons during the year. Earth is a terrestrial planet, meaning that it is a rocky body rather than a gas giant like Jupiter. It is the largest of the 4 terrestrial planets in size and mass. Of these 4 planets, Earth also has the highest density, the highest surface gravity, and the strongest magnetic field. It is also the one that has the fastest rotation around the sun. The shape of the Earth approximates an orbit spheroid, a sphere flattened along the axis from pole to pole such that there is a bulge around the equator. For this reason, the furthest point on the surface from the Earth's center of mass is the Chimborazo volcano, which bulges out if you can see it from outer space. So the average diameter of the average diameter of the sphere is 12,742 kilometers, which is approximately, the mass of the Earth is approximately 5.98 times 10 to the 24 kilograms. It is composed mostly of iron, oxygen, silicon, magnesium, sulfur, nickel, calcium, aluminum, with the remaining consisting of traces of other elements. Due to mass segregation, the core region is believed to be primarily composed of iron, of 88% of iron, with smaller amounts of nickel, sulfur, and less than 1% trace of elements. Now, while we're talking about elements, I have a joke for you. What do you call a periodic table with no gold?
What?
Au revoir. Ha ha ha. Okay. So, geochemist F.W. Clarke calculated that a little more than 47% of the Earth's crust consists of oxygen. That is also a reason why human life can flourish on Earth and not other planets. The most common rock of the Earth's crust is mostly oxide. Never mind. Okay. The Earth's crust are nearly all oxides: chloride, sulfur, and fluorine. The principal oxides are silica, alumina, iron oxides, lime, magnesia, potash, and soda. Basically, Earth is known to have many, many elements. The interior of the Earth, like other planets, is divided into layers by their chemical or physical properties. But unlike the other terrestrial planets, it has a very distinct outer and inner core. For Earth, the outer core is we can live on, and the inner core is, well, I'll get to that. The outer layer of the Earth is chemically distinct silicate solid crust, which that's why we can live on it. And the inside is mainly magma, so we can't really go in there. The mechanically rigid outer layer of the Earth, which is the lithosphere, as I talked about it earlier, is broken. The tectonic plates are rigid segments that move in relation to one another at one of the three types of plate boundaries. Convergent boundaries, at which two plates come together; divergent boundaries, at which two plates are pulled apart; and transform boundaries, in which two plates slide past one another like laterally. Earthquakes, volcanic activity, mountain building, and trenches in the ocean can be formed because of the tectonic plates moving. The tectonic plates ride on top of the asthenosphere, the solid but less viscous part of the upper mantle, which is the inner part of the Earth, and the solid but less viscous part of the upper mantle that can flow and move along the plates. That's what allows the tectonic plates to move. As the tectonic plates migrate across the planet, the ocean floor is subducted under the leading edges of the plates at convergent boundaries. At the same time, the upwelling of mantle material at divergent boundaries create mid-ocean ridges. The 7 plates are the Pacific, North American, Eurasian, African, Antarctica, Indo-Australian, and South America. Other notable places are the Arabian Plate, the Caribbean Plate, and the Nazca Plate. The Earth's terrain varies greatly from place to place. About 70.8% of the surface is covered by water. Much of the continental shelf below sea level. This equals to about 361.1.3 million kilometers. The planetary surface undergoes reshaping over geological time due to tectonics and erosion. That's why if you looked at how the Earth was a few billion years ago, it would not have this many. Maybe it would look different. Okay. The Earth's atmosphere has no definite boundary. It's slowly becoming thinner and fading into outer space. So that's what global warming is. If we keep on polluting our atmosphere, then it gets thinner and thinner, and we have less protection against the sun and its rays. Now, I have a few jokes. What did the sea say to the shore?
What?
Yes? Yeah. Okay. A tree couple got in a fight. What did one tree say to the other? Pack up your trunk. I'm leaving you. Okay, I have another one. What did the moon say to the earth?
What?
I earth you. That's all.